This next lesson focuses on conversions within the SI or the metric system. So as we can see, this lesson is going to be conversion within the metric. The next lesson is going to be between the metric and the imperial systems. And then finally, we're going to take a quick look at if we do square units or cubic units. So if we're doing it for area or volume, it's going to change around the way that we do it just a little bit. So you can use this chart if you want for the metric system. It's a good way to use as a reference to see that, oh, well, in every single case, it's just on a base 10 system where I'm going down by a tenth or a thousand, or I'm going up by tens or thousands. Basically the same way that our counting units work. If I'm doing the conversions, then if I'm moving from left to right, my numbers should get bigger, even though my units are smaller. If I'm moving from right to left, the numbers should get smaller. So if I'm going from a gigameter to a meter, which is the basic unit at 0, then that means that there's going to be 1 billion of them. If I'm going from a megameter to a meter, there's 1 million of them. A kilo, you should already know off the top of your head, is 1,000. If I'm going from a centimeter to a meter, that's going to be 0.01. A millimeter is going to be 0.001. A micrometer is going to be 0.000001. And a nano is 0.000000001. Now, remember, this is just the placeholder because it doesn't actually say which of the metric units we're using. So we did those in terms of meters. If I do it in terms of liters, then I could say that the main part here would be liters, which means that this would be a megaliter, this would be a milliliter, and so on and so forth. The same thing could work for grams, the same thing could work for whatever metric unit we need to use. So 1 liter is the same as 1,000 milliliters. 1 gram is the same as 1,000 milligrams. And 1 kilogram is the same as 1,000 grams. A milliliter is 0.001 liters. A milligram is 0.001 grams. And 1 gram is the same as 0.001 kilograms. When we're doing the conversions, we can use a number line, and for some people that makes it easier because the number line is just stating how many points in the base 10 system we're going to use, or we do it the same way that we would if we're doing scientific notation, where we say that we're just going to, if we're moving to the right, multiply it by 10 to the power of how many moves we had to do. So in this case, if I went from this unit to this unit, then I would have to go times 10 to the power of 4. Or if I'm moving to the left, I'm going to do negative units because I'm moving to the left. So if I went from this unit to this unit, I had to do 3 moves to the left, so I'd say that it's whatever the original unit was times 10 to the negative 3. So, if I'm using the metric unit number line to complete the following, then we can write each answer as a power of 10 in standard notation. So 1 meter, starting at the base unit, if I have to go to the centas, is going to be the same as 10 to the power of 2 centimeters. 1 millimeter, start at millis, go to the base unit, is going to be 10 to the negative 3 meters. And 1 liter to a milliliter is going to be 10 to the positive 3. If I'm converting the following measures, then I'm going to say that if I have 7.5 meters that I want to make centimeters, then it's going to be 7.5 times 10 to the power of 2 centimeters, which is going to be 750 centimeters. If I had milligrams to kilograms, then I'm starting at my millis, I'm going to kilos, and I need to move to the left 6 times, which means that this would be 72350 milligrams would equal 72350 times 10 to the negative 6 kilograms. This would be the same as 0.07235 kilograms. If I'm going from micrometers to nanometers, micros here, nanos here, and I had to move it 3 times to the right. 325 micrometers is going to equal 325 times 10 to the power of 3 nanometers. Which means that this would be the same as 325,000 nanometers. If I want to convert the following, leaving the answers in scientific notation, well, then going from kilometers to millimeters, I would do 12 times 10 to the power of 6 millimeters, which in proper scientific notation would be 1.2 times 10 to the power of 7 millimeters. If I'm going from micrograms to grams, then this is going to be the same as 580 times 10 to the negative 6 grams. That's going to give me 5.8 times 10 to the negative 4 grams in proper scientific notation. And if I go from centiliters to megaliters, this is going to be 15700 times 10 to the negative 8 megaliters, which would be the same as 1.57 times 10 to the negative 4 megaliters. We can also use proportional reasoning, which is a common method that we use in later courses. In mathematics, proportional reasoning is a statement of equality between two ratios. This is where you probably would have come up or heard the term cross-multiply in the past. So if I have A over B and it's equal to C over D, if I know 3 of these values, I can solve for what the last one would be using cross-multiplying. Multiply the diagonal and then divide the horizontal. or divide the vertical. So, Alice, Jim, and Rima were asked to convert 300 centimeters into meters. Part of the work is shown. Each knew that 1 meter is the same as 100 centimeters. So the way that Alice approached this was she said 1 meter divided by 100 centimeters, the ratio is going to equal x meters over 300 centimeters. The next thing that she did was she multiplied both sides by 3, which means that in this case x is equal to 3 meters, which means that 300 centimeters would be the same as 3 meters. How did she get there? Well, when she multiplied both sides by 3, she said that 3 meters over 300 centimeters is equal to x over 300 centimeters. And then just canceled out the denominators. For Jim, he said 1 over 100 centimeters is equal to x over 300 centimeters. And he multiplied both sides by 300 centimeters. And then multiplied both sides by 100 centimeters, which is how he got 300 on the one side and 100 on the other side. Then, because he had x over here, he divided both sides by 100 centimeters. Because they had common units, centimeters divided by centimeters would cancel out. 1 times 300 divided by 100 is going to be 3 meters. And he got the same answer. For Rima, she basically did the same thing. She rearranged the way that she had it stated, but it still winds up working out the same way. She multiplied this over here, she multiplied this over here, and then she divided by the coefficient, and also got 3 meters. Both Jim and Rima used cross multiplication to solve the problem. Notice that the centimeters cancel out every single time, leaving just the units of meters.